everyone. We'll get started in just a few minutes as all of the pipes start going. All of the streaming pipes. Say hello in the chats. No, my audio's working. Everything else too. Hope everybody had a good week. Oh, I'm not even in the right channel here. It's a sad song. How's everyone doing? Good afternoon, David. Hello, M4TK. One more minute and then we'll go. Haven't seen anybody say hello in the Discord yet. Or the restream. Hi, Johnny in Discord. Where's the chat on the Discord Adafruit? It's in the live broadcast chat channel, David. And if folks want to join, this is a good segue. You can go to adafru.it/discord to join the Discord server. The nice thing about Discord is it's a chat server that happens all the time, not just when I'm streaming here. So hello, my name is Scott. I work on CircuitPython for Adafruit. CircuitPython is a version of Python designed for little tiny computers called microcontrollers. I have a lot of non-Adafruit boards on my desk, but I'll show the one I showed last week. So Adafruit is an open source hardware and software company based out of New York City. So for example, this is a macropad. You're welcome. Hello, Shujat, and hello, Doug TDY8892. This is called a macropad. It's got a little tiny computer in it. It's an RP2040, which is a little tiny computer. It can run CircuitPython. It can also run other code, but CircuitPython is kind of the thing that we teach people to use. You plug it in, it shows up as a CircuitPy drive. There's a Python file on it. You edit it, and hit save, and it'll automatically rerun your code. So the goal is to make it really easy to get started programming computers and devices like this. So Adafruit takes microcontrollers from other development vendors and puts them on specifically designed circuit boards for all sorts of different projects and teaches you how to use them through Learn. So if you want to support me, you can go to adafruit.com, purchase hardware stuff like this. This is the Adafruit channel. That's what it's all about. Yeah, so let me say more hellos. Hello, Relic. Says, congrats on getting the first Zephyr ports merged into the core. Spoilers. Yeah. Hello, Beata. Hello, Doug TDY. Do you know if Adafruit will ever open as a walk-in store? I don't think so. I don't think they'll ever have a walk-in store. Yeah, I think if that's something they wanted to do, they would have done it already. I should say I do work remotely for Adafruit. So Adafruit's based in New York City. I live in Seattle, so I'm streaming from Seattle, and that's why it's already 5 o'clock on the East Coast, but not here. Hello, ADCC. Glad you could make it. So Relic gave a little bit away. So I've been working on building CircuitPython on top of Zephyr. Zephyr is an open source real-time operating system. It's being quite popular. Vendors are supporting a lot of it. And we're looking to make it easier. There's a few things that we're looking to do. One, we're trying to make it easier to add support for new chips. Because the more chips we support, the more devices like this we can make with different functionality and capabilities from different chip vendors. That's one of the main motivations that we got to where we are, is that we want to make it easier. Prior to this, we were more focused on doing like software on a per vendor basis, but that's a lot of work. Frankly, it's a lot of work. So the hope is that if we can target Zephyr and the vendors are targeting Zephyr support, that we have less to do. DCD points out as well that they do have same-day delivery in New York, if you are in New York and you want something same day. Hi, Timon, as well. So that's one of the reasons Zephyr is really interesting to us. Another reason is that there's just things that we would like to support that we'd like to just add support for once. BLE is the canonical example that I point to. So BLE is Bluetooth Low Energy. We currently have 3 different implementations of that in CircuitPython, and it's kind of outrageous. We have one for Espressif, which is based on Nimble. We have one for Nordic, which is currently the soft device. And we have one for the external ESP32 SPI, which is like derived from Arduino Bluetooth Low Energy. So that's really annoying to have to maintain 3 different versions of BLE, for example. And so we're hoping to get a lot of shared code for Bluetooth and Wi-Fi and networking, because that's kind of where Zephyr, people who use Zephyr want to be able to do those things on different chip vendors. Okay, so that's the ideal. One thing that I didn't fully realize beforehand, but has been really nice for Zephyr as well, is that we benefit from basic board definitions, so information about what's connected to a certain microcontroller on different boards. So you can basically run CircuitPython in a limited way on any board that Zephyr supports, which is like 400 plus. We also support over 500 in CircuitPython, so there's like, I don't know how much overlap there is actually between the two. But then we also benefit from like Flash APIs. So like one thing we have to manage is like internal versus external Flash and like layouts and stuff like that. So we can unify that code on one Flash API, and that's really nice too. So Relic, as Relic said, the initial Zephyr port is currently checked in. So the next release will include like five or six new boards that are all based on the Zephyr work. So I did 3 NRF boards, the NRF 7002, the 5340, and the NRF 54L15. So these are all newer Nordic boards that are going to be hard to support in our current Nordic port. So we're basically, all the newer Nordic stuff we will support using Zephyr, which is what Nordic themselves is doing. So those 3 are in there. There's 2 ST chips that I just thought were interesting, and like one of them has SDRAM, which is pretty cool, which is like 60, or I think, is it 32 or 64 megabytes of external RAM, which is really cool. So I got that working just because it was interesting. And then the other 2, I did the Renesas RA6 and RA8 boards. Those are chips that we've had our eye on as well. So those are, again, like basically any new boards that we want, any new chipsets that we want to support, we'll do through Zephyr. We won't do directly through the vendor house. Damon says, I had the tab of the recording of last week open instead of the live stream. It took me a minute to notice. Well, I'm glad you did. Glad you're here. Yeah, so the basic Zephyr support is checked in. It has like stubbed out Wi-Fi support, but it's not fully fledged. So I had to take a bit of a detour to do that. Last week I had gotten into doing the build stuff because Lady Ada was trying to build it. She hasn't actually circled back to that, so we'll see where she's at when she gets back to it. But we got it checked in, we got the CI working. I did also have to update our Python formatter. All right, I chose to update our Python formatter for Python code that's checked into the core. We were using Black, and some of my changes caused us to update Black, and then we changed things, and I was like, I don't want to do that. I'd rather just use Rough, because that's a new linter and formatter for Python that the world is moving to, because it's way quicker. It's actually written in Rust, and it's just way quicker than Black. So I did that in order to get the CI fully passing. So that's all checked in, and now I don't have this like to-do item on my list of doing all the build stuff and getting it checked in. Now I can go back to the Wi-Fi stuff that I was wanting to get back to, and I can do a follow-up PR. So that's where I'm at. This week I've not done a ton of work because my eldest, I have 2 kids, one who's a baby and one who's a kid, basically, going to daycare. He's been sick, and we had a couple snow days here in Seattle too, so I've not managed to have a full week's worth of work. Although it was kind of convenient for when I was fixing the CI to like do 10 minutes of work, push it, let the CI run, come back to it, fix it, let the CI run. So that was, it was not all bad. But that's where I'm at. I did get over a hurdle. I had this, one of the things that I had left off with trying to do Wi-Fi connect is that it was crashing pretty hard. And I figured out this morning why that was. And it turns out when you turn, so I'm testing on the Nordic NRF 7002, which is an external coprocessor chip. Oh, and I should say, I don't think I said this. Folks who watched it before, if you have questions, feel free to ask them, even if they're unrelated to what I'm talking about. I'm happy to go on tangents and answer questions. So please ask questions if you have them. So it turns out that when I turned on Wi-Fi and I turned on the wpa-supplicant, which is something that is inherited from Linux, and I'm a little horrified because I discovered that like to interface between Zephyr and wpa-supplicant, it actually like forms command line strings, passes it in, and then parses strings back. I was like, it's just kind of wild. But apparently that's what it does. And what I discovered is that when wpa-supplicant is turned on, libc malloc is turned on, and if you use libc malloc, it automatically puts a heap past the end of the image in RAM, which turns out exactly what I was doing for CircuitPython as well. So I was getting crashes because I had 2 different heaps in the same place, one that was CircuitPython and one that was the wpa-supplicant stuff. So once I told Zephyr to just say like used a fixed size for that malloc heap, I don't know why they have so many different heaps. Once I told them to do a fixed size of that malloc heap, it put it back in the like Zephyr image of the RAM, and then the remainder was okay for us to use for CircuitPython. So I'm not crashing anymore. Good. I'm also not managing to connect still. And it's actually a consequence of me having worked at my house most of this week, and now I'm here in the office, and the office's Wi-Fi is different than my house's Wi-Fi. So I am trying to connect correctly, but I am failing to connect because I'm looking for a network that is not here. And instead of just changing my network and seeing that it works and moving on, I was actually like, okay, how do I actually get information back that says like, this is what happened. Here's how you, like, here's the exception that I need to raise. And then that once that exception is raised, then I can change my network credentials and see if the good path works too. So that's where I'm at. So I've got, this is kind of the spoilers, but so in radio, we are doing connect. I'm printing it out. I'm setting the connection parameters. I'm doing lots of prints. And then I call this net management thing. And Wi-Fi connect, and it was after this that I was crashing because of the heap thing. And then I've got what I learned from a few weeks ago is that like I need to wait because if I return too early, I'll turn everything down. So I've got just some long waits in here to see kind of what events I get back, and then I can replace that with waiting for specific events, which is actually what this commented code out is doing. Like when you said checked in, did you mean to your tannewt repo or CircuitPython, like on CircuitPython.org? Yes, it's merged into main. It's merged into main, so with the next release, we should get the boards showing on CircuitPython.org, and they should be available. They are obviously alpha state, but yeah, the pull request has been merged in. So if we pull up this and just go. Dan didn't have any feedback, so I'm sure there's stuff that's going to change, but Pull requests, closed, add Zephyr port. So it was merged in 2 days ago. We've had 3 ta-das, or hoorays. It's merged in. I broke something, so Jeff fixed it. So thank you, Jeff, for fixing my bug. Not surprised. But yeah, so the main stuff is all checked in, 466 files. Ooh, Relic's got a question. What do you anticipate the process will look like once you begin to move chips currently supported by CircuitPython into the Zephyr port? So I think the first one that's going to happen is probably the Nordic port, because this is another motivation to move to Zephyr, is the newer Nordic chips are, like the NRF54 L15s are available, and the H20s are going to be available soon. And the H20 looks like 54H20. It's pretty awesome. It's like 400 plus megahertz, I think. No, 320. Multiple M33s clocked up to 320. Multiple RISC-V coprocessors, a meg of RAM, Bluetooth, lower energy, LE audio, Bluetooth mesh, thread, matter, high-speed USB, blah, 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 blah. It's like, they put a lot to it. It's like, pretty cool. So kind of what I expect to happen is that we will, yeah, so Timon says, I'm excited for CircuitPython on the NRF5340. So that should be checked in right now. You should have basic NRF5340 support with the Zephyr port currently. But this is, I think, why I'm going to live in the Nordic part of the Zephyr port for a while. So basically trying to implement as many features as I can of CircuitPython on top of Zephyr. And then for the features I can't, I still have to do like per vendor stuff. So for Nordic, that means that I think what's going to happen is I'm going to have to update the Nordic port to a newer version of the vendor HAL, which is called NRFX. Turns out we're using like a 5-year-old version. So we need to update that to the same version that Zephyr's using. And then we should, I'm hoping to be able to turn on selectively modules in the Zephyr port that are actually implemented in the Nordic port. So that's my plan. And then I think once, when I build the NRF52840s in the Zephyr mode, but I still have the same capabilities, then we'll just swap them basically, and retire the Nordic port build. We'll still have the directory because it will probably still separate like how our vendor HAL specific implementations of things. But yeah, does that answer your question about how that'll look? The hope is that you won't see changes on the, if you're a user of a certain board, you won't actually see changes, hopefully. I used it a lot and I've really been missing something quicker to prototype with. L15 has no USB, unfortunately. Would that still qualify for CircuitPython? Yes, so this is a misconception. We did a really good job telling people we only do native USB stuff, and then like 2 versions or 3 versions back, we stopped doing that. And we stopped requiring that when I introduced the BLE workflow. So it was like, if you don't have native USB, but we have this BLE way of doing CircuitPython. And since then, we've also added the Wi-Fi way. And we actually are okay with doing the UART way as well. Code.circuitpython.org can handle all of those for you. So yeah, we're okay with boards that do not have native USB. People still get confused by that, but we're okay with it at this point. So Timon says, merge the soft device port together with the Zephyr port. Wouldn't it make it more sense to replace it fully? So I think there's code in there that we're going to want to reuse, right? So we're going to, like, if we want to do dynamic UART, there might be a way to do it with Zephyr. We have to explore that. But if there's not, then we want basically the same NRFX code that's in the original Nordic port. And that may be true for other vendor implementations as well, because Zephyr is really built it on top of the vendor house. So we're building what we can on Zephyr, and then when we're not able to, we'll just go straight to the vendor how that Zephyr uses. So one big thing before we can kind of unify to the Zephyr Nordic port is like we have to implement Bluetooth on Zephyr, like our CircuitPython Bluetooth APIs on top of Zephyr, which I'm very excited about. And we may actually be able to, once we do Bluetooth, that may actually make it pretty easy to do like we have a couple small ports that I think do like the Scilabs port does Bluetooth, I think, but we could probably do Bluetooth through Zephyr on the Scilabs chips and then like pretty quickly fold that together as well. So yeah. Might cause trouble, or you would have to make your own sock definition so that the Zephyr device model is not aware of the hardware bits that you don't want managed by Zephyr. Yeah, we'll have to figure out how to coexist there, but we can also hack Zephyr to be less tricky about it. Like the Zephyr folks are having active discussions about like de-initting things as well, so we'll see. We'll see. There's another world where we don't do that, or yeah, it's unclear exactly how much we can do on top of Zephyr directly. I think dynamic peripherals should work out if you're okay that CircuitPython reboots on code change. Like reboots? Like, no, that's not okay. Like, we don't want to lose USB. We don't want to lose the USB when peripherals change. I've chimed in on the issue about dinit, so we'll see. Arduino is pushing it too. They say they want it as well. John says, can you take a quick step back and explain the whole Zephyr thing? I must have missed something. Lamore and Phil never give any backstory. So, sure. Zephyr is a real-time, so way back when we were thinking about Bluetooth, originally doing the Nordic port, Nordic had their own soft device, and we just targeted that. That was like CircuitPython 3. I thought CircuitPython was the end all. So we're just doing, one day I start hearing the name and I don't really know what's going on. I'm sure others are in the same boat. Yeah, so Zephyr is a real-time operating system that we watched for a lot of years. But one of the things that really caught our eye, there used to be like two competing open source real-time operating systems. One was called Minute and one was called Zephyr. And there was this like, with the NRF52s, Nordic did soft device, but they really wanted to move away from that model. And so they ended up choosing Zephyr, and Nordic has put a lot of their effort into the Bluetooth stack. They wanted an open source Bluetooth stack, and Zephyr is that thing that they decided to work in and build on. So Nordic has gone all in on Zephyr for a while. We've watched it a lot of years for something to build on CircuitPython on top of, but had a lot of criticisms because it's very fixed. It's meant to like, you know, be in like your headphones, right? Where like it's not being dynamically programmed at all. You have this fixed function that's all you're gonna do. So we had followed it a lot of years and didn't really kind of like, didn't think it was a good fit for us, but we kept watching it, and we see more and more vendors adding support for their chipsets to Zephyr. And then I had a second kid. I had my second kid at the end of October. I was out pretty much all of November for that. And then when I came back, Lamore said, hey, like, you have a lot of leave coming next year, so this year. Is there something we could do with my time back that would make it easier to support new chipsets? And because vendors have adopted Zephyr, like if we build CircuitPython on top of Zephyr, we can support any chipset that Zephyr supports. So that was the key question about like, that was the key motivation to do it now is I'm not gonna have a lot of time this year. Once I start taking leave again, how can we make it easier to support different chipsets? And then there's all these other things that we've been thinking about with CircuitPython. So having a real-time operating system is really nice. We want to get to a world where we can actually run parts of CircuitPython on different cores at the same time. And managing different tasks and things that we're doing is made easier with a real-time operating system that it does like threads and locks and queues and mutexes and stuff like that. So there was like two ways we could have gone there. So the Espressif port is another big one of ours. And we did BLE support there, but like they use Nimble, but Nimble is really like doesn't have the vendor support that Zephyr does. It's, yeah. What does Zephyr change as far as a developer? Do I still program in Arduino or CircuitPython? Yes. Yeah, Zephyr is the thing that underlies those two things. Yeah. In the same way that like in CircuitPython you're programming Python, you're not doing C. In CircuitPython you would still be doing Python, not C. But the hope is that by switching how the underlying stuff is done, you'll be able to use more chipsets. You'll have CircuitPython on more chipsets. And then on our side, there's less work for us to do to support a new chipset. So if Scilabs has a Bluetooth chip or a Thread chip, like we only have to just build it and run it. We don't have to like take our Thread or Bluetooth API and make it work with the vendor's API, because now instead of targeting our CircuitPython code, our internal CircuitPython code to a vendor specific like API, we're targeting to a generic API that then the vendors implement from their side. Did I indicate we don't want to lose resources like USB on reboot? Are there non-reboot ways for CircuitPython to deal with changes? Yeah, so yeah, I don't want to do a full reset of we don't want to do a full reset of the microcontroller every time you do a code.py change, because then your USB drive will disappear and catch up. No problem, John. This is exactly why I'm like, ask me questions. I'm not great at writing documentation, but I can sit on a stream for 2 hours and answer questions. So this is what it's all about. And Mark points out, if you think about how you run Python on, say, Linux, this is CircuitPython on Zephyr. Right, so instead of CircuitPython being on top of a specific vendor, HAL, so like Raspberry Pi has their Pico SDK, and Espressif has their IDF, and NXP has whatever it is, blah, 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 blah. Like, we target as much as we can Zephyr, which then is implemented by those vendor SDKs, but the vendor is doing that work, not us. Although we're going to end up doing some of that work, I'm sure. But yeah, hopefully it'll still get us a lot further. Yeah, and like in the Zephyr port, we don't have to manage like compiler flags and stuff. So John says, can I recommend that Adafruit do an intro to Zephyr for dummies video or article? So I think it's a little deceptive that we're talking about Zephyr a lot, but the reality is you don't need to know about it, right? Like CircuitPython should still be the same thing. If I'm developing a product, what should I do right now regarding the introduction of Zephyr? I mean, that's not really like, we don't expect people to use Zephyr directly on our boards. Instead, we're choosing to build the new software, the software packages that we provide, like CircuitPython, for our boards just on something else. So like, this is a deep dive, so I'm talking about it, but like, at the end result, if you're using CircuitPython, you shouldn't care. But there are actually learn guides for Zephyr that were done a little while ago. So learn.adafruit.com, and then if you look for Zephyr, there is a Blinky by Lucian, who used to do a lot of work with us and is actually starting to do a little work with us again. So there is a learn guide for it. It's been a minute. I don't know how out of date it is because it was written originally 5 years ago now. So I don't know if it's been updated. Will libraries stop working at some point and my firmware will need to be adjusted for the new underlying code? So no. So in CircuitPython, we do major version releases whenever we expect you to have to learn what's new and maybe adapt to it. This Zephyr stuff will not introduce any API changes for Python code. If I do it right. It should all just work the same from the outside. It's just powered by something else on the inside. And I think that's the goal with the Arduino stuff. So Arduino is moving to building on Zephyr as well. But again, they don't, unless you want to know that it's Zephyr under the hood, you shouldn't need to know. David says, what is the importance of supporting new chipsets? What is it you cannot do with existing support chipsets, and what would you be able to do? I think there's a meta point about supporting new chipsets, which is like, in a world where we don't know what's going to be available and at what cost, it gives Adafruit more flexibility to switch quickly to things that are lower cost and can do the things that we want. I'm always looking for new functionality that chips have. So one thing like the ESP32P4 is something I've talked about a lot, and it has like CSI and DSI, which are higher speed camera and display interfaces. More chips have multiple cores and more RAM. So SD-RAM support is something that's really cool, especially for CircuitPython where we're like very RAM heavy. Being able to make boards that have SD-RAMs on them would be really cool. So that is, yeah, so the meta point is that it's easier for us to switch and go towards like chipsets that are interesting for both price and functionality. And then it also like gives us some tools to use on existing stuff as well to be able to better structure the internals of CircuitPython. DCD says the discussion is CircuitPython and Zephyr, but is there a similar, maybe automatic way to associate Zephyr to Arduino that some Adafruit customers use? So I don't think so. So there is work to build Arduino around on top of Zephyr, and the Arduino people are doing that. I think the history there, and I don't follow Arduino that closely, but Arduino was targeting mbed, which was an ARM product, but ARM decided to not support mbed anymore. So when mbed was turned down, Arduino announced that they were going to start targeting Zephyr as well. If the Zephyr stuff does not change the API, will you change the CircuitPython major version number? So there's another reason to do a major version number, and that's for marketing. We usually do put a few API changes in there as well, and sometimes it's file format version numbers too, with a new MicroPython update, but I wouldn't rule us out deciding to do a major version number just to make a marketing splash when we felt Zephyr's support was mature. But I think we're planning, I think we want to do CircuitPython 10 before I leave. So like the beginning of May is like when I go back on leave. So I think we're hoping to do 10 before that. And Dan just opened an issue on TinyUF2. But the major thing that's going to come with CircuitPython 10 is the ESP32 S3s will no longer support the OTA partitions so that they can support Bluetooth Low Energy. So we're going to change the bootloader so that the partition is a single OTA partition, not two. And then CircuitPython 10 will require that you have the new bootloader because it will be larger firmware, because it will have BLE. So that's probably going to be the main 10 thing. Timon says, this week I looked into the IMX RT500 for a project that might be super interesting for CircuitPython. It's 5 megs internal SRAM and 2 really fast external memories for RAM and flash. Yeah, but it's probably really expensive. And DSI, CSI, parallel RGB display support and other nice stuff. Yeah, NXP does pretty good support for in Zephyr 2, like you were saying. So, Relic says, I hope Zephyr's specific features, i.e. multi-core, are ready by 10. Don't count on it. We won't be able to take advantage of Zephyr and the internals really until we're completely or pretty much all switched over. And that's not going to happen by 10. That's going to happen like after I'm back full time at the end of this year, when my youngest goes to daycare. So before I come back and like finish and polish it, it's going to be Zephyr on the side, and we won't be able to like do a whole lot kind of outside of that port scope. So yeah, don't get your hopes up for that, but like it would be great to do Bluetooth before, like Bluetooth on Zephyr. Although I'm doing networking, I'm doing Wi-Fi right now, so we'll get this new Wi-Fi chipset, and then I want to do Ethernet as well. So another board I've got sitting on my pile is this board, which is an ESP32 board, but it's got Ethernet on it. So CircuitPython doesn't have native Ethernet support. There is a WizNet library that can give you Ethernet from like Python userland, but Ethernet support is in Zephyr, so it shouldn't be too hard to, hopefully, knock on wood, have like native Ethernet support pretty easily. Yeah, Zephyr does have multi-core support. I looked at all of the boards that support it, and they're expensive. Time-sensitive things more easy to do due to real-time. Not necessarily, but we have this current system in CircuitPython called background tasks. So if you're doing display updates or audio, like we have separate times that we need to run code for that. And we have this background task system, and MicroPython invented their own kind of equivalent to that too, when the reality is like that's really what a real-time operating system is better for. Whether you want to make them separate tasks or threads, or whether you want to do something like a work queue. I don't know, but one thing I'm doing when I'm going through this implementation, and if folks have ever seen this in CircuitPython, if you have an API like connect where you're going to wait 5 seconds for something to happen, you actually need to do a for loop that calls run background tasks in it. And I'm getting rid of that. So like now and that's what Mark's saying. You sprinkle run background tasks around and just to make sure that things run. USB is also included in that. But when I'm doing all the Zephyr work, I'm actually not doing that. So instead what I'm doing is I say, just like real-time operating system, wait until this thing happens or this thing happens. So for Wi-Fi scanning, there's 3 ways that I can 3 things I'm waiting for. And if any one of them, should I show you this? Yeah, sorry, I read David's questions. David says, how many additional babies would you like to have in our family? The answer is 0 additional babies. We just plan on having 2. And did we consider twins optimization to have more kids but less parental leaves? Hey, I don't think you should optimize for fewer parental leaves. I think it's good to take time off to spend with your kids. And I cannot imagine how hard it is to have twins. We would have done that if we had to, but we didn't have to. So yeah, let me show you what I'm talking about with this waiting thing. So if we look in, let me adjust my window size. So we are in Radio, and let's do start scanning. So this is if you want to get the results of a Wi-Fi scan to see what networks are around you. So we are, and this is true for other ports as well. What we do is we return this other object that acts like an iterator. So you can say for every network in ScannedNetworks, and then you can do stuff. So what I'm doing here is I'm actually initializing both a message queue and a FIFO. So this is all real-time operating system-y things. So a message queue is a fixed buffer of a fixed number of results of like a fixed size, and then a FIFO is kind of a list of pointers. But what happens is that I get a call back from the real-time operating system saying, hey, you got a new scan result, and then I add it to the message queue. And then I have to shuffle that off from the message queue to the FIFO, and then I can return it up to Python when I'm ready. And I'm initializing this kpoll event thing. So kpoll is the mechanic that you can use to say, if one of these 3 things happen, come back to me. Relic says those arrows and not equals in Sublime are funky. Yeah, it's called ligatures in your font. So it's actually 2 characters, like if I put a space here, but the font itself can know that like if these 2 characters are next to each other, then render it this other way. So it's a font function not specific to Sublime Text. It's the font that I've got. And it's called, the feature is called ligatures. Talk about tangents. Final thought on that tangent. If you look up nerd font, it's a thing that takes a font and then patches stuff into it. So it's like FiraCode. FiraCode is the one I use, and then nerd font gives you all sorts of little stuff. Does it say ligatures? Maybe it's a FiraCode thing, which is the font. With programming ligatures, yeah. Okay, tangent, pop the stack. What was I talking about? So the polling API is how you can say that you want to wait for 3 things. So let me go to ScannedNetworks and go to next. So this is how iterators work, as you say. In your for loop, you do for something in this object, and then it calls the next function. And then this is where we wait. So we say, hey, if we're done, just return none. And then that stops the loop. And then if our FIFO is empty and our message queue is empty, then we wait and we don't, and then we're like stopped. We're stopped, we're waiting for some new result so that we can continue that CircuitPython loop. And we actually have to wait for a few things. So we wait for the message queue. We wait for the done signal. So the message queue holds the results if we find networks. If we're done, then we get a signal, and then we can also be control C'd. So control C works by having a semaphore that is not available, and we say, hey, if it's available, then wake me up. So we check, hey, if we're interrupted, then we're done. If our message queue has something in it now, we found something. And then if we're done scanning a certain channel, then scan the next channel. Otherwise, if we're completely done, then return none. And then also, before we give you something back, we say for everything in the message queue, 'cause this is coming from the real-time operating system kind of into the CircuitPython realm. We get it from the message queue, and we allocate an object for it. So we like try to keep the message queue. It might find 5 networks, and if we found 5 networks, but we're only going to return you one, we'll actually make objects for all 5 and store them, so that we can quickly give them to you. So that's what we get the oldest result for you. And we don't have to wait because we know that there's something there. So the actual like suspend this task happens with this k pull, and it's on 3 events. One is I got a new scan result, I finished scanning a channel, or I've been control C'd. And like Mark is saying, that this is instead of run background tasks, because with a real-time operating system, although this thread of CircuitPython, the VM, is suspended, we can have other threads in the real-time operating system that still run. For example, TinyUSB. So TinyUSB runs as a separate thread now, which means that it can still run if like we're waiting here. Was that clear as mud? And the sun's come out, so my lights are not bright enough. But the hope is that it makes it easier to manage all these things. Although it is a little unfortunate that like pretty much every time we have to do pull, because we always have to either wake up if we have a result or we've been like control C'd. I'm going to turn my lights up so I'm a little less shadowy. Actually helps my eyes too. Although now my monitor's kind of dark. I can raise my monitor brightness too. Or not. I guess that was only on my laptop that I can. Any other questions about that? ADCC says, very nice, great alternative to cooperative multitasking. It turns out that Zephyr can do cooperative multitasking too, which I thought was pretty cool. So if you look at Zephyr thread priorities, it might just be on here. They have a good diagram for it. Like thread states, stacks, thread priority. So if your priority is 0 or higher, you actually have less priority. If you are 0 or fewer, then you're actually a cooperative thread, which means another thread won't interrupt you. You can finish your work and then give it back. So CircuitPython runs at 0. TinyUSB runs at -1, I think. So TinyUSB now is like waiting to get messages on the message queue as well. Is that JetBrains mono? I think it's FiraCode is what I use font-wise. Okay, so I had to do something similar for connecting to Wi-Fi. That's where I'm at. I need to get myself in a state where I'm waiting for the results of connecting to the Wi-Fi, or I've been control C'd. Unfortunately. Unfortunately, I'm going to have to pretty much always poll because of that. So that's what kind of one thing I've been working on. So I'm actually going to sneak and snag this. And put it in connect. Let's just do that. So instead of these just weights, we are going to do so this wait for the semaphore to be available for MP interrupt sem is the waiting for control C. And then I think instead of doing this one, I've got to go to scan networks and do signal init. That's what it is. I thought, you know what? I think I'm just going to call it done. Done. Wait for done. Done. And we're going to put this in the second slot. Object is self done. And then we'll do a kpoll. There's a lot to fill out here. Oh, it's in this other file. That's why I don't have it. And we can poll forever. Although this would be another way to implement the timeout. I'm not actually going to implement the timeout that way. So when you do a connect call, you do give it a timeout, but I'm passing that timeout kind of down the line. So I shouldn't need to manage it here. So I'm just going to do kpoll, and then I will say if I'm interrupted. So this is a little tricky because I actually do want to, I think I want to clean up well. So maybe do we need to disconnect here? And then we'll just return. Is that what it is? Okay, so now if we're interrupted, otherwise we are going to get the signal check. So we're just going to do the signaling. And if we aren't signaled, then something bad happened. I should look and see what my options are for these. None, unspecified. It should have been, yeah, we'll just do unspecified. Ooh, funny. David says, is the Fruit Jam RP2350B the MicroPython retro computer we have been waiting for? What currently missing features do you think are needed for making it real complete? Keyboard workflow is already supported, maybe a built-in editor or a file manager. Yeah. The answer is yes. Although maybe I should say this is a top secret, don't ask, or don't ask, it's not out yet, or whatever the phrase is. But yeah. So they've been teasing this Fruit Jam RP2350 as a new upcoming product, and yeah, I think we're gonna be. It's gonna have more than just CircuitPython for it, but yes, that's yeah. I think it's gonna be a really. So David asks, what features do you think are needed for making it real complete? I think USB host needs a lot of testing, and I'm sure there's bugs around that. So there's going to be some work about making gamepads work and making keyboard work, and MIDI host maybe working better, for example. And then keyboard workflow is already supported, maybe a built-in editor or file manager. Yeah, I think we should figure out how to like ship with a code editor too, and figure out like how to switch between those things. I was actually thinking about using the F keys. So if you hit F1, it runs your code. If you hit F2, maybe it runs like f2.py. And we could like just name our code editor f2.py or something. Relic says they got FiraCode working. Awesome. But yeah, that's the goal. It's meant to be like an emulator, RP2350 emulator sort of thing, and also like the CircuitPython all-in-one. Yep. Like Jeff just added, if you watch our pull requests, he just added support for auto starting the HSTX. So we basically see if you have a display plugged in when you start up, and if you do, then we'll automatically start the display for CircuitPython. And the other secret about this is that the Metro RP2350 can do a lot of these too. So the Fruit Jam thing is like the Metro reformed or reshaped. But yeah. Yep. It should be cool. ADCC says, will it have the RM2? I don't think so. No. I'm not sure we can get them. So no Wi-Fi currently planned. I haven't actually watched the things that they've showed off with it, so I don't have one either, although I think I might get one like next week. We'll see. That was on show and tell the other day too, waiting for both that and the Metro 2350. Yeah. RP2350 has RISC-V cores, so it should be able to run some minimal Linux. Yeah, I don't know. I don't think we're going to run Linux on it. It's going to be emulators that are not Linux. If somebody wants to do Zephyr work, there is an open issue about doing, it's called SMP, symmetric multiprocessing in Zephyr on the RP2s. That would be really cool. That would make it easy, and we'll probably push that forward once we get there. But that would be really cool to be able to use Zephyr's SMP on the RP2s. So that would be great, because the current supported boards for SMP and Zephyr are all at least $150 or more. So I did not impulse buy any of them to see if it works. Okay, if not signaled, then we return. Otherwise, we'll do a print. Okay, and say connect done with a value, and it's going to be the results. And now what we do is, and this is a little funky, but we'll just do it the direct way. This is going to have to be redone a little bit if we have multiple networks, so like Wi-Fi and Ethernet, for example. But I'm trying not to get ahead of myself. Let's take a look back at how things are signaled and scanned. No, it's actually done in here right now. So if we get a scan result, we call this thing, which we just put it in the message queue. And if we can't, we print out. Otherwise, we send a signal here. But in what we can do instead is signal raise, self-done, status. Okay. ADCC says, where can I find more info on the RP2 SMP support? Well, let me find the issue for you. Let me tempt you. Zephyr SMP. Will I find it in my... Here we go. It is issue 59,826. Like, there's a lot of support. Not anymore. The MMU requirement has been dropped a few kernels ago for Linux. Yeah, I thought it needed MMU too, but I don't follow Linux development. Relic says, that would be incredible if certain boards could be loaded with all the utilities to run as a microcomputer out of the gate, putting straight into a REPL prompt. Writing and testing firmware directly on the target board is a super neat idea. Yeah, I think the question of what the workflow is actually kind of interesting. Like, do you want to go straight to the REPL, or do we want to say we run code.py, which is what we do now, and we shouldn't change that. But if you press F2 and you haven't taken over the keyboard, then we'll exit code.py and we'll run f2.py or whatever. And that could be for all the F keys, for example. We could just say, like, if you press F10 and you have an f10.py, we just switch to that one so that you can, like, I don't know, is it silly? Is it silly to have, like, F2 is the code editor and F3 is the name of the file system manager and F10 is the synthesizer or whatever? Like, is that silly to do that? I don't know. Sometimes the right thing to do is kind of obvious like that. So if folks have ideas about how to do this, let me know. And I would expect me to, I think I will be doing some of this work for the Fruit Jam. So come back for another deep dive when I have hardware, and maybe we will play around with it. No, you don't need to resist. ADCC has been doing awesome work on the RP2 stuff. You don't need to resist, just do it. It would be awesome. I don't know anything about what SMP is needed, but people will be stoked. Somebody's been assigned. I don't know who they are or why they're assigned to it. But they have been. DCD says there have been eras where the function keys were very part of the PC environment. Yeah. Yeah, the other place we're going is, like, there is this notion of fantasy consoles. And it is actually like this. I was thinking about the status bar too. So maybe what we do is we say it is f1.py, but then we can say, like, somehow know, like, the name of it. So it could be, maybe it's like f1 dash something, and then in the status bar we could, like, have an f1 and then the name. So it would tell you, like, what it is. But I kind of think that's, like, I don't want two Python programs at once running. Like, man, we could theoretically have two VMs at once, but that's I don't know how well that would work. Although the split heap stuff, that's an option. That's an option. Yeah. David says, would you consider releasing again a product in small test quantities during a deep dive? Have I done that before? It was probably happenstance. Generally, Adafruit products are done in a small batch to start. Relatively small. Yeah, so I'm curious to see what people think about this idea of like, I don't think I want to dump you in the REPL. I think like code.py first and then Beata says, I'm wondering split I2C kind of stuff. What do you mean split I2C kind of stuff? The terminals in the office on Severed have a great feel. I've not watched Severed, but maybe I should watch it for inspiration. I mean, I'm not going to lie, like Pico 8 is definitely, if you haven't looked at Pico 8, this is definitely like the vibe that we're going for too. I don't know. Let me see if I get, do I get sound? Yeah. Like how cool is that? And then you can, I thought you could escape. I don't know what it's doing. I was saying, I do want to chime. I don't know what the controls are. Relic says, ooh, I love Pico 8. Wish the port to the RP2350 was done. Yeah, there's what, is it Yocto 8? Is that what it's called? It's on our radar. Pico 8 cartridge runner for the RP2, for the Pico 2. Yeah. Yeah. Commodore 64 and the ZX Spectrum, they all drop you to the REPL. Yeah, I don't think I want to drop you to the REPL though, because that changes the way CircuitPython works. I don't want to, I still want CircuitPython to be CircuitPython. We have the REPL, but I don't think I want to just like not run what code.py is. Maybe if, no. I don't know, we can play around with it. Okay, so lovely tangents. Okay, so we're doing k-pole signal rays on done. And I'm passing the status. And should we just do that? So yeah, if you have ideas and vision for what a CircuitPython standalone computer, you have a mouse, keyboard, potentially with a DVI display. If you have ideas on what that looks like, let me know. Channel done. 384. Yeah, radio error interrupted is not right. This is where I get in trouble using Copilot. It's like, yeah, that would make sense. It doesn't. It's not right. We'll do unspecified and signal check, and it's not channel done. It's just done. And we can reuse that for other things too. But yeah, I kind of feel like F keys are where it'd be cool, and like, yeah. David says, I think I have a one or two CircuitPython 2020X's on the topic. I may need to review those. Retired Wizard says the retro machines used to drop you to basic maybe drop you to a modified REPL like your basic Python shell. That's an interesting idea. Like what code.py, what it is that it ships with is an interesting question. DCD says, how do you nudge Copilot to do what you want? One way to do it is to copy and paste like relevant strings in the context. Kalahari says, what are you doing, my friend? I don't know what you're doing. Teach us, hackers, please. I'm working on getting Wi-Fi connection working in CircuitPython and just chatting about stuff. ADCC says, sometimes I run Copilot just to see how wrong it can be. A great example of when Copilot's really nice is like, if you look in here and I'm doing all these prints, what I do is I copy the enum and then I copy the enum, put it in a comment, and then I start typing this big long switch case, and like it can do each case automatically for me. It's really nice. But it also does make stuff up if the context deceives it. Okay, so here we got Common HAL, Wi-Fi, Radio Connect done, minus 116. So this is annoying. This is annoying because I was tracing through this. So if we pull up, there's a Wi-Fi management.h. And the status that you get back is somewhere here. Request parameters, connection status. Okay, if you get a 0, it succeeded. If you get a 1, it failed. Wrong password, timeout, AP not found, and then this is the last one, whatever. However, the value I'm getting is not in this list, which is quite annoying. I'm actually getting E timed out instead of status connection timeout. So I think what I need to do is I need to say in my Wi-Fi connect. So it is coming back, which is great. If result equals Wi-Fi, and is this actually a thing? No. Let's see. Already connected to the desired network. Trying to switch networks. Auth fail, no AP found. Wi-Fi radio error none. I don't actually know. What we returned. So this is the implementation copied from Espressif. ADCC says, yeah, me too. It really excels at generating tables. Yeah, it does. It's handy for if you have the thing that you want in one format and you're just trying to have it to mimic into a different format. It's really helpful. NP-HAL is interrupted. I guess I don't know if there's a way to say that I timed out. Retries left is 0. You know what? We may not have the full implementation. Let's just pull up the actual code. I might have deleted it. Wi-Fi, radio, tries left. Last disconnect reason. What could that be? I think we'll just do unknown for now. Like, I'm not looking to be perfect. Let's see. Connection fail. Oh, here's a reason timeout. Okay. Let's just do that. Okay. Wi-Fi reason timeout. Else if I guess we need to do the like make sure if we're on the right thing already. Hey, that looks right. Wrong password. AP not found. Otherwise none. Oh, I did it like, yeah. Python. And we don't need this else. We just return it. Okay, let's see what other things we're doing. I don't know how we check whether we're connected or not, but it's definitely meant to be idempotent like this. So I don't know how to get the current status. We might want to do that first. The BSS ID we are doing, we say if channel, oh no, oh yeah, if BSS ID. Okay, so we're doing that. We do the channel thing. We don't do retries, but I want to do it without retries. Here's run background tasks like Mark was talking about. We don't need to manage retries or timeout. Disconnect reason, we don't care. We don't need to reset the number of retries. We are setting the channel and the password and the SSID. We are not doing this event group stuff. We are not doing connected already. So we need to know if we're connected, and so let's just do check to see if we're connected. If we are to the network we want, then return immediately. If not, then disconnect. Which I think is what it will do. Is that what it does? I think what I'll do is I'm just not going to do this right now. I'm going to do it kind of like this though. If we are, then return not. Return immediately. If not, then disconnect. And that's what this is doing. So let's just delete it. I actually want to, we've got 40 minutes. I actually want to see if I can get connected. Ooh, but you know what? I think if we're connected is There's a name for it. Where did I do it? I have some prints. Dormant. Carrier OK versus dormant. Not dormant. Zephyr network dormant. Phi status is carrier on, carrier off. An example of an event that changes the dormant state is a Wi-Fi driver successfully connecting to an access point. In this scenario, the driver should set the dormant state to on during initialization, and once it detects it is connected to the network, it should be dormant state off. Hi, FedA2. Is this one that says if up? What did I put up? Oh, that would make netif is up make more sense. Okay, so I think what we do is we just say it's connected. It's just this. Okay. So let's flash, and now I gotta change my credentials. Uncomment my other credentials, and we'll see. I'd love to get a socket. How cool would that be? Wi-Fi reason. Okay. Isn't that what it is? I'm actually going to make this default to unknown or unspecified. And I'm going to check the positive case. That was a pretty good suggestion, I think. Oh, radio error. That's why I can't find it. The last thing it generated was wrong. Radio error. Okay. Let's try that. This should be the first board. Well, CircuitPython doesn't have it, but this board supports 5 gigahertz Wi-Fi as well. So there's room to add support for that. Error. There's no Wi-Fi error timeout. Oh. I was looking at the wrong thing. Hey, look, here's an error with 3 R's. That's not right. I doubt it's used anywhere. The real answer is that I know that the AP is not there, but the driver is not. The Zephyr stuff doesn't tell me that there's no AP. wpa-supplicant tells me, but like I could add code to Zephyr to get better error messages here. I'm gonna try not to do that though. And the sun went away. Beata got sucked into the font stuff. Oh yeah, it's a good place to be. Let's see. Let me lower my brightness. Save my eyes. Now that not competing with the sun. All right, it's flashed. So this is the NRF 7002 DK, but it's actually an NRF 5340 talking to a 7002. So CircuitPython is running on an NRF 5340 in this example. Talking to the Wi-Fi chip separately. Zephyr is doing all that for me. For folks in the Adafruit system, it's kind of like the airlift style. Except it's not running the same firmware. It's whatever Zephyr is loading onto it. It's a blob. It's a binary blob. I think it's flashing twice here because it's I'm also putting all of the Bluetooth stuff on the second core. So the NRF 5340 has 2 cores, and this HCI IPC is actually Bluetooth support. So when I was figuring out how to get it all building, I turned on the Bluetooth side of things too. Okay, so we got to that point. Let's see what we're getting in CircuitPython land. So I'm going to plug in the other USB port. And, oh, that's not what I want. I'm going to split, and I'm going to do to So we have NRF 5340 USB working in the Zephyr port. So if I just do Control D, let's see what happens. So it does the scan. And then it's connecting. Unknown failure 1. Okay, that's fine. This is actually my access point, but it's my work access point. So I'm going to switch away from my desktop. Well, actually, let me show you. I do have CircuitPy here. I'm just going to edit settings toml while you just look at me. Even though I've probably shown my settings before. I probably might print them out too. Okay, so I saved my settings. I'm going to go back to my desktop and we'll see what happened. So it reran. Oh! It got connected, but then it failed to do the get. And it got a name or service not known. So we're getting somewhere. Status 2. Wrong password. No, here's a connect that worked. Status connect success, but then we turn it down and we confuse everything. Adafruit connection manager line 33. I wonder what it's doing. So now I got to figure out what it's like, what the next step is in this example. So I'm gonna escape it, or I ejected it, and I will use this to see its output. I'm gonna unplug the native USB, because when I turn it off and hang it, it gets confused. Why disconnect after success? So CircuitPython, if the connection is initiated by the user, then we will disconnect at the end of code.py. If it's not, if it's an auto connect, then I don't think we do, which is interesting because I'm actually saving my credentials, so it should actually auto connect, although I don't know if I have that enabled in the build. Because like one of the cool things would be if like web workflow works automatically over all this networking stuff. Okay, I want to pull up Adafruit Connection Manager and just see what it's doing. Connection Manager. Hmm, 3333. It's calling get address info. Get a new socket and connect to host. Do we already have a socket? Okay, so we're calling get address info. So if we go in here in socket pool, get address info raise. If true, raise the error that we're getting. Okay, so let's add a print here and confirm that we're getting that far. This is another place where like Copilot knows what I want. I just want to add a print. And in fact, what we should do is we could, so I pulled up merge and let me move it. Let's just clean some of the other things away. We've got 20 or 30 minutes. I want all this stuff here. This stuff is really useful. I want that. I want this. I want this. This is what I just added, but I also have my Zephyr open. I guess this is all my prints. Scan started. All right, let's just try it. It's not that many prints, I guess. Why disconnect after success? Like part of the reason is like, generally if once code.py is done, we want to leave state the way it was. Because we want you to start from the same place the second time you run code.py. But yeah, it's a good question. What should we ship on code.py? I think there's a pending PR for my basic Python example. Somebody did ages ago. Not sure it's that useful, but. Supplicant event BSS removed. So I think this is net event supplicant internal event. And actually, that's what we could do is we could tell it we don't want to listen to those right now. So this is how you do it. This is another bug that I ran into. So there's all these network events that you get from Zephyr. I do not like their network management API. I do not like it, Sam I am. And I've tried it, and I know I do not like it. So you say, hey, net management init event callback. Like, call this callback, or here's a callback object to initialize, and here's the function to call, and here's the events that I want to hear. But if you combine, see, I'm doing this thing 4 times, and it seems to me, or it seemed to me, that you could do it all once. Like, these are separate events. But it turns out these event values, they are like numbers mixed together. So there's like a category and then a single thing, and it checks the category during the callback. But if you or ones of different categories, you end up putting them in a different category altogether. So it doesn't work. So you actually have to do like and I think that's why there's this like prefix, right? Net event Wi-Fi, net event IF, net event L4, net event supplicant. It's like, don't mix those because it doesn't work. It's not at all obvious, but it doesn't work. Okay, so it said wrong password again. Although that was the second time. Now, we got a connect success, but then it went down, and then we got net event interface down. Why did we get a down? And then, but then we're doing get address info raise. So I guess we need more information on this net event interface down. This is another gripe I have about this, like, really, it's not even an API to me because it's not well documented at all. So if I get a network event interface down, it gives me an object, but it doesn't tell me what kind of object it is. So success means we're connected, but I don't know if that means that, like, maybe the down is like we never got an IP, or like I need to turn on DHCP. Like, I'm all new to the Zephyr stuff, so like there might be a subsequent thing I need to do. Let's figure out this net event interface down thing. So the way that I've been figuring this out is if it's like not even an API. It's not documented. It's not documented. It's not C functions. If it was C functions, at least your compiler could verify things. So we're here. And now let's go to the Zephyr website. Or maybe here, we'll search their docs. And what does it say about this? The only place it's mentioned, or at least that search finds it, is in this net event.h. And it's the event emitted when the network interface goes down. What the heck does that mean? And what sort of info are you going to give me when that happens? Let's see. Event notify, interface down. Here's the shell. Admin up. Connection manager, handle interface down. So I think DHCP v4. Yeah, interface down can have many causes. Do you know how to see what the cause is? I don't know. Like, these are all shell event. Which one do we think is actually... It's probably this function call is what is being called. Update operational state. Who? Let's netf.c 5561. netf.c 5561. And let's just print K here. Let's see if we get that. Behind suggests looking at netif operation unknown, not present, down, layer down, testing. It could mean disconnected from the AP. I'm listening to the events of the... I'm also listening to Wi-Fi like disconnected events. I don't know if I'm running DHCP. Okay, I'm gonna have to end at 4. Netf operation dormant. Netf operation up. I don't know what those things are. What is behind? I don't know. This is my criticism of Zephyr. All I have to do is figure it out once, right? The problem is, I think, because it's so poorly documented that it means that all the vendor implementations are not going to be very good. So I suspect, I was just thinking about this, I suspect and worry that CircuitPython may be a strong forcing function to fix a bunch of Zephyr stuff. Because we're actually checking inconsistencies across vendor, like we're going to run into a bunch of problems like that. I could also stop taking it down. That may be confusing things too. Okay, here's the scan. Trying to associate. Network interface up. Failed to get random data for S nodes. And then we get the interface down. Wrong password. Interface WLAN 0 not found because I turned it off. I should stop turning it off and see what happens. What is behind? I don't know what that is. What is this thing you speak of? AI-powered search engine. I see. not helping me. This warning, though, is helpful. The pre-shared key may be incorrect, but I thought we got success. Failed to get random data for S knots. I think I'm going to maybe I'm gonna add a sleep. Let me add a sleep after I do. If I connect successfully. Okay. K-sleep. Seconds. Let's just do like 30 seconds. Let's just see what happens. I see. Oh, I get it. It's find with a PH. Not helpful. Failed to get random data. Let's look at that. RSN support wpa-C704. OS get random. ESP IDF. Huh. I'm surprised there was no Zephyr. Like, this could be something where I just don't have it enabled. No. How is this supposed to work? Like, I thought I had random on. Source utils OS internal. Oh, there's an OS Zephyr. Sleep. Make time. random. Entropy has driver. This is, oh, return 0, okay. OS get random entropy. See, like, that was fine. Okay. How do I tell TO to clear? Clear screen, no. Okay. I should have looked at that before I did it, but. Oh, and it cleared the screen a little bit. I still have all the scroll back. It's kind of annoying. All right, we're building. Any final questions? We have about 10 minutes left before we're gonna go. I will get this checked in and pushed because that's how I like to back things up. In fact, I could do that while it's doing it. I don't actually care about the state. This is pushing just to my Zephyr-Wi-Fi branch. And this timeout might be throwing us off. I'm gonna just discard that. Do I want to discard it? No. No, I think I want to do something about like AP not found. Because I think it will keep looking and looking and looking and looking and looking. It won't actually return. So I don't think I want to have an infinite timeout ever, actually. And this I do want to stage. This other stuff I don't really care about. Okay. And I'm just going to push it right now. More Wi-Fi work. So this says timed out. OS get random entropy. Failed to get random S-naughts. So it's trying, and it's giving me a password failure, but I'm like almost positive the password's correct. So if it's complaining about getting random data, let's dig into this. csrand get if entropy reseed error. And formatting is like slow still. Sadison says, totally unrelated to Zephyr, but I want to connect two of the 64x32 matrices together. I've been using Arduino to show stuff on one matrix and it works great. On Adafruit.com it says it should be possible to connect two matrices together, but the Adafruit library doesn't support it yet. Any ideas of where I could look to figure out how to make this work in Arduino? Look at protomatter. I think Arduino is using it. Both CircuitPython and Arduino use GitHub, Adafruit, I think it's underscore protomatter. So this is the this is the library that we use. So between this and if you look in CircuitPython, how we use it, that might be able to tell you. I think it should work. I know we can do multiple matrices in CircuitPython. I mean, I understand that I need a random value. What I don't understand is why Zephyr is not giving me a random value. And my formatting is still going, huh? Does this... have my bug in it? I think it has the bug in it. I thought... oh, you know what I need to do? I need to rebase. I fixed this bug. It's the wrong password. I'm gonna be confused. No. Okay. Force with lease. Mark's taking a look for you too. Yeah, that's what I'm thinking too. But I thought I had it connected to. Thought CircuitPython random was also connected to it. csrand get. See, we're calling it. And we are going to do modules. Tests. Subsystem. Random entropy device is my guess. I thought we had it enabled. The other thing we can do is look all the way down. If we can guess, oh, you know what? We can look at Nordic, Zephyr, DTS, entropy. Entropy is the Bluetooth HCI. So I wonder if we're not turning Bluetooth on to get entropy from Bluetooth? Bluetooth HCI entropy. How silly would that be? So now if we look in, I gotta get out of here. Zephyr. Drivers. entropy, Bluetooth HCI, get entropy. Do not wait for Bluetooth to be ready. All right, last one. I'm gonna clean and flash since I did the rebase. HCI is different from the Bluetooth controller. You can have the Bluetooth host running on one part, but radio on another. Front end. Huh. This will just tell me where to dig Monday. It's so weird to me that it's Friday. The radio might not be turned on necessarily. Need to be turned on? I mean, it's weird that random's not working. But these are complicated systems, and I assumed that all the kconfig fanciness and device tree fanciness meant that things would actually be initialized right, turned on right, but that has not been my experience. Like, device tree says status okay, and then like you haven't turned on the kconfig that you need, so it doesn't work. Oh yeah, that's in my debugging. What? You know what? I think maybe this Zephyr one's a lie. Yeah, it's not libc anymore. Open repository. New repos. CircuitPython. Ports. Zephyr. All right, here we go. Discard this. These are heap debug statements. All right. Connect results. Timed out. Failed. Returned minus 134. We found the right spot. We found the right spot, and we are getting the problem. So that is a thread to pull on Monday. So thank you all. It's been wonderful deep diving with you and really digging into the Zephyr stuff. Check it out. It's in the main repo now. If you want to work on it, it's there too. Join us on the Discord channel. If you're not in the Discord, URL is adafru.it/discord. I said that fast because I realized how it's 5 minutes past 4. You want to support me and Adafruit, go to adafru.com, purchase there. And yeah, thank you all. We'll see you. Dear old -134. See you next week. Bye.